both between ESA and the different Chinese entities and also multilaterally. For me, the project which I have very close to my heart is a project called SMILE. It's developed together with the Chinese Academy of Sciences, and it's also for the study of solar winds and magnetic fields, magnetosphere. But what is interesting with this is the setup, because, and this is something which I think is unique, it has never been done by any other international collaborative bodies, but it was because of, so the leaders of the ESA Space Science program, together with the heads of the Chinese space science at the Academy of Sciences, decided to say, okay, how can we foster collaboration between our two sides? How can we get scientists working together? So we made a sort of a fictive small mission, and then we invited the community from both sides, from China and from Europe. And we told them, okay, what would you do if you had such a mission? So we had 120, we met up in Chengdu, and we had like 120 presentations. And then we said, okay, together, ESA and the Chinese Academy of Sciences, okay, we meet again in 5 months' time. And the criteria to present is that you have to do it jointly. And after that, we had maybe 45 presentations. And after that, we could issue a call, and then we selected through peer review in Europe and in China, the SMILE mission. So it's a completely innovative and a project which is based on trust. And that is, everything is, international collaboration is about trust. And that is something which has been fantastic to follow.
Well, yes,
So
for you guys, I noticed the two key words. The first one is a cooperation. The other one is a joint mission. And now, at the current time, we got a message from the Facebook. Is a commentator, his name is Arkal Ni. This person said, the good thing about the space mission is we never heard the news about the astronauts and cosmonauts fight each other in space. Well, this is a really good thing. And another one is, I guess, is from Japan. Its name is UC Kimutsu. It just gives a comment awesome to your comments. And another thing is that when you talked about the joint mission, the joint effort, the concerted effort, there's one thing just Mr. Xu Yuansong just mentioned about the avoiding the collision in space, because just the few days ago we know that the NASA is going to seek the information from China's Mars mission and try to avoid the colliding of the Mars rovers in space. And back to the Earth, the orbiting, there's so many satellites. This is also important because the joint mission. And another thing back to DeKalb is we heard back in the past 5 years, China and Europe signed a joint statement of the Common Development Plan from the year 2015 to 2020. But after that, would there be any further agreement?
Of course, definitely. So we have a joint cooperation plan that was signed a few years ago with the 2015 between ESA and the China National Space Administration, which gives us, if you want, a roadmap for what we should do together. It's the leaders from both sides who say, okay, this is what we should, what I think we should concentrate on and how you should work. And just recently, about a few weeks ago, there was another conversation between our newly appointed Director General and the Administrator of CNSA, Mr. Zhang Kejian, on, okay, we should now, when we can, we should sit down and do another plan for what we should do together. And I think that the trend, I think, is really to, whatever we can do together, we should do together in space.
Yes. Another question is constantly from our feedbacks from the internet. It's from Facebook. It's a question of how about those satellites that are not working anymore? Are they just floating around in space? And so in this sector, what kind of international cooperation is being undergoing, Mr. Xu?
Yes, I think I've just mentioned about the IADC, International Space Debris Coordination Group. This was originally formed by 14 space nations, space agencies, and then was further expanded to almost 20 countries. This multilateral mechanism has 4 working groups. Those working groups are basically for observations, for data compilations and modelings, for protective protective gears, like preventions and mitigations. And these working groups are coming up with guidelines. For example, these guidelines has been submitted to the United Nations and passed the UN legislation as a guideline for all space activities. So basically, what we're doing by this working group is that the launching of all rockets, the final stage of the rocket also enters the space. So that final rocket has to go through a process called passivation. Passivation process basically means that you vent all the fuels remained and discharge all the batteries and all the compression components. So it becomes very passive in orbit, and it will gradually re-enter the Earth atmosphere and burn up in years or decades' time by the drag. And others, space debris, space activities, including the satellites. When you launch the satellite, you have to design it in such a way and fashion that by end of its lifetime, it has to be deorbited, either to enter the atmosphere or to go to a graveyard orbit. So this will remove those space debris in a way that in the beginning of the process, the designing phase, you have already started the consideration of the abandoning and cleaning up the space environment. And also, there are also historic missions that also leave a number of space debris. We have to think about innovative ideas like capturing the space debris, like collecting the remaining satellites as litters. So we compile them together, either to refuel them or to bring them back to unused orbit. So these are some things that are being done internationally, and some of the technologies are also innovative. So we're trying to clean up the space environment. Giving you one example is that just on 24th, I think 3 days ago, the Dragon mission to the ISS, the astronauts was required to dress up with a mask and space suits, so that a possible close proximity of the space debris might threaten the safety of the Dragon capsule. So that was a very close proximity space debris issue. So very fortunately, it was not collided, and the astronauts was successfully docking with the remaining crew. So now the ISS has the biggest crew of 11 people on board. So space debris, as you said, also the collision avoidance in Mars orbit, and probably in the future the lunar orbit, also can be considered as one element in the future construction of a space traffic management system, so that all data are compiled, a sustained space environment can be maintained, and we can extend our presence in future space. So this is also very important for those countries launching magnet constellations. So we have to keep ourselves constantly aware and alert that space environment is one area that we have to protect and preserve.
So back to a few months ago, we observed the night sky, and because there is a launch from the SpaceX, it's about the star chain. This is a future chain of the satellites. So for this regard, is this the only way for the countries to launch their individual satellite network? So what about this kind of the satellite network, for example, like the star chain? Would it be a possible way to reduce the cost and reduce the debris in the future? Back to you, Carl.
Well, I think when it comes to the debris, I agree, this is a fundamental issue, in particular for the next generations, and we really have to be very careful. And I think there are lots of work that is being carried out in order first to monitor, to track, and to see also, so how do we handle this, in particular with all the new constellations that are coming up. There are many constellations that are being deployed, as you were mentioning, and there are constellations that will be deployed. And in order, the only way for us to all coexist in space is through common rules, common regulations, etc., on how we handle this. What do we do with the satellites if they don't perform? Do we put them in graveyard orbit, or do we try to get them down so that they burn up when they enter the atmosphere? So it is interesting in that sense, because it's an area where you cannot survive without international cooperation.
Yes, yes.
Because
so let's go a little bit further from the orbiting the Earth's satellites or the space station. Let's go to the moon, because back to the end of the last year, there is a Tiangong 5 mission to bring back the lunar sample from the Earth in 40 years. Chinese government has announced that it welcomes the cooperation from the international community. Has the ESA accepted the invitation and begins the cooperation and analyzing the lunar samples? Cal.
Yeah, so we received an invitation, and of course, within ESA, we do not carry out that type of science. So what we did is that we contacted, of course, all the universities and research institutions, and to see whether they would be interested in how they could interact on this. So I think it's the Tiangong 5 mission is a fantastic mission, because it provides us with samples that from an area where we did not have samples. So the scientists working on planetology are extremely thrilled to be able to analyze the sample from Tiangong 5 and comparing them with the samples from, say, the Apollo missions, because it will be very, very interesting to see, you will be able to calibrate the date and how old the moon is, basically, because Tiangong 5 landed in an area where there were not so many craters. So it is thought that it is younger area than where the Apollo missions landed. So scientifically, it's a fantastic tool.
Yes, you've been participating in the Tiangong series missions, but for the Tiangong 6, the next missions, what would the ASA is going to do with China?
So we have I think there are some countries within our member states that will participate on a bilateral basis directly with CNSA. And I think France is discussing, or I don't know if they have concluded, but there are some member states that are participating. What the ESA support, and that is to be seen, because as we mentioned before, ESA has been cooperating with the Chinese Launch Telemetry Tracking Centers. That long-standing cooperation between our center and the Chinese center. So most likely there will be some.
Well, it seems the network is not stable at the current time.
Relations and some development. Yeah.
Okay, hold on for a second. Let's get back to Mr. Xu. China and Russia just announced recently, as both countries going to co-build the lunar base in the future. So, what do you think of this kind of the decision, and would that decision to become a reality? How many years would it take to become a reality, and what kind of the invitation to the international community, and what kind of concerted efforts need to co-build that?
Well, I think the lunar base is one of the very innovative ideas. The moon has been considered very useful for deep space missions. For example, if humans want to go beyond the moon, go to other planetary bodies, you need the moon to be a stepping stone for your future missions. So this requires the moon to be a fueling station, to be a station, areas that you can practice on the uncooperative bodies to maneuver yourself in microgravity environment. So a lunar base is very important for study these areas. The in situ resource, or they call lunar volatiles, is very important to find waters on the polar areas of the moon, and also to have a constant presence on the moon by robotic missions. That is the ambition of both countries like China and Russia. We are in the planning of Tiangong 6 and Tiangong Plus missions, and Russians are working on Lunar 25, 26, 27, and further missions. All of these are compatible missions that we have. Both countries have same target of study the moon robotically first before we send the human to the moon. So it's unlike the U.S. missions. The U.S. missions want to go back to the moon by 2024 or 2026. They call it boots on the moon, but it's very ambitious because human presence on the moon requires a lot of engineering and bigger infrastructures. So the firm believer of China and Russia on robotic missions to the moon will bring the international community together. I think both sides have extended our invitation to the international community to join this effort. European Space Agency, ESA, have called for a lunar village before. And also, like the previous Director General of ESA said, we don't want to go to the moon just to paint it red. We want to have scientific missions so that we can work together. I think collective efforts will always bring us further. Let's say a single person travels, he can travel fast, but a group will travel further.
Well said. And Cal, back to ESA, what's the recent voices towards the plan to co-build this lunar base by China and Russia, and also with the effort from the international community?
Well, first of all, we're all very excited about this initiative that comes from China and Russia. We will of course also, we have just basically learned about it in a recent conversation between Mr. Zhang Kejian and our Director General. So we will also have to address it with our member states, which is the decision body of ESA. But in general, of course, it makes absolutely sense to collaborate when we do such a complex thing as exploration. As Xu Yansong was saying, doing it by yourself might be fast, etc. But if you want to do it sustainable, then you should do it through international cooperation, because international cooperation is, of course, it takes longer time, but it's much more sustainable in the long run. So, and also what we can do to reduce cost, everything you do in space is expensive. So if we can share communications, if we can share some elements or whatever, it's good for everybody. So I think it's really a very interesting initiative that has come up now recently.
Well, that's the reason why the NASA is going to seek the collaboration from China, especially on the Mars mission, the Perseverance, and especially on the possible the Chinese Mars mission is going to take the further step in the next month. So what's your perspective on this side, especially on Mars missions, the collaboration between the countries? Because the United States is collaborating with Saudi Arabia and also China. At the current time, the three countries, their probes are currently working in different position above on the surface of Mars.
Yes, as you know, the Mars proximity to Earth is the close proximity occurs every 2 years. So that is why all three missions were launched in November last year at the same time, almost the same time, and arrived in Mars orbit almost the same day. And also we had this U.S. mission successfully landed on the surface of Mars, and also had the first flight of the helicopter or the UAV of Mars. So very impressive missions. And during the discussion of the state counselors between the two sides and the U.S. and China, and even the U.S. mentioned about the mission on Mars. Of course, China also have this Mars mission Tianhe. We're going to launch. We have just named the lander.
The lander.
3 days back on the Space Day of China on the 24th. So that will be landed on the surface of Mars. Deep space exploration missions always requires more infrastructures. More global efforts. For example, the Mars mission, the communications and the orbit management and autonomous missions are very challenging to each mission. The distance between Moon and between Earth and Mars has always been changing, but it's roughly 8 to 10 minutes for communications. So one-way signal is 8 to 10 minutes. So both way would take roughly 20 minutes to get a response. So communication is one issue, and also the coordination of the orbit and the landing site, as well as the scientific targets, are different. So we can study Mars by joint efforts. US, Europeans, UAE, and other countries, along with China, can study the Mars atmosphere and the surface at the same time. So I think Mars missions are challenging to the international community, not only human resource, technologies, and space facilities, but also infrastructures like telecommunication and tracking and control. All of these requires global efforts. I think coordination among countries and joint study of scientific objectives can be done by any country, because these are less sensitive, is for purely for peaceful purpose, and there's no reason why we should not stop. We should stop the scientific community to work together, including U.S. and Chinese scientists.
So we all hope that either the rover from the U.S., UAE, or China could collaborate together and share some very valuable information to improve each other. Back to you, Cal. So besides, let us go further into the space. After the space station, satellite, and also the lunar base station, and also the Mars missions, what's next for the international community?
I think we will all continue to explore, because mankind has it in itself we have to pose ourselves the questions, and then we have to try to seek the answers. What is further, etc. So I think it will be a progressive way on how we go. And I think today we have the focus is on Mars, of course, that you will see several, I think we will see some very interesting mission now when the Tianhe rover is landing on Mars. The next step, I think, will be Mars sample return, and that will be by the end of this decade, perhaps, that we will see the first entity which goes to Mars, picks up soil or samples, and then bring them back for analysis on the Earth. That will be a gigantic step. And after that, I think we'll go perhaps to missions to Jupiter. That is also very interesting. And I think that we have a mission to Jupiter looking at the Jovian moons, etc., towards the end of the decade. I think, as I said in the beginning, it's something we have in us. We want to know, we have to better understand. And also, we do these things not only because we want to understand, but it's also to understand and also to be able to apply it on the Earth, to protect our own little Earth. Because the more we learn about the surroundings, the better we know how to protect our Earth.
Well, yes, there's a sharp question from from the feedback on the Facebook users. One more question, maybe off topic: can space be used for the dumping place for nuclear debris? So, because in the future, perhaps the nuclear power could be the driven force to push the spacecraft into the deep space. So, this question would be a little bit complicated or sharp. So based on your knowledge, what would be the next part for the international community to design the better energy to send the spaceship into this deep space? What would be the possible and most reasonable energy?
Well, I think use of nuclear energy in outer space also has already been regulated by the United Nations. We have legislations to follow. To use nuclear energy in outer space has been strictly restricted and controlled. Of course, we use different forms of energy. For example, on Mars mission and Moon missions, we use radioactive isotope instead of nuclear reactor. Nuclear reactor is very powerful, but also is very hard to control in outer space, in particularly autonomous status. We use radioactive isotope as a heating element. It can function more than 87 years in outer space. If you see the movie Martian, the character is using the radioactive isotope to heat up his vehicle inside. That is also very. It's also dangerous if you expose that material, but We use that for lunar missions to heat over the lunar nights, which is about 15 or 17 days. And the dumping of nuclear waste in outer space is strictly forbidden because of the international laws and regulations. But I don't want to explore, want to go further, because it is the status that we're in, where technology are not so stable that you can launch and then orbit into outer space with guarantee that there's no accident. So if you launch some space debris, some nuclear waste from Earth, and the launch vehicle exploded in mid-air, you would see there was even more serious pollutions. So until we guarantee that approach, we cannot do it at this moment. Maybe in the future we have, maybe you can send it to deep space as a waste. But this is something that it has not been done or regulated by UN, and it's not practical at this moment. It's a good thinking, but I think also at this moment we're doing, instead of sending things out, we're bringing things in. This is called space mining. We study or capture some of the asteroid. Some of the asteroid maybe have precious metals, or even diamonds, or some other materials that is strongly desired on Earth. But also this activity has also been highly restricted by the international community. Only Belgium, other few countries, have passed the legislation to allow these activities to happen. So these are new areas, as you mentioned, beyond the Moon and Mars, maybe asteroid, maybe capturing uncooperative bodies, study the solar system, and many others.
So as to my understanding, from your description, I understand this is part of the international collaboration, because this is a common standard applied by the entire world based on the international conventions. So
yes, there is an international space treaty, and under the treaty there are 4 or 5 space legislations and regulations. Those including the study of the moon and search and rescue registrations and other treaties that has to be followed by the international community. And also we have the United Nations Committee on Peaceful Use of Outer Space, and those are also providing guidelines and long-term sustainability practice for space activities. So there's a code of conduct for all space activities, and space should also should be only used for peaceful purpose.
Well, so these kind of the insightful and opinions impressed our audiences, and from Facebook, Twitter, and they also raised the we also got the nice future based on the international collaboration. So before you go, there's a question raised by a lot of the our readers and audiences. And this question raised to you, Cal, and to you, Yansu, is with all kinds of the concerted efforts exploring into the orbit of the Earth, the Mars, the moons, and also the deep space. So what would these efforts bring to all the human beings, to each one of us on Earth? From you, Cal, you first.
Well, I think that it brings us knowledge. It brings us. We know very little of what surrounds us, and this is a fundamental tool to know more, to better understand the world around us. And if you take, for instance, we talk a lot about climate and environment. Studying Venus, the planet Venus, is a very good example to see what happens if you don't have any ozone layer. So there are applications that are comes directly from these exploration missions that we have carried out, and I think that this will continue again and again. And we have the case of asteroids, for instance. How do we protect Earth from asteroids? We have to learn. Should we, in case we have a situation in 100 years where you have an asteroid which would be aiming towards Earth, what do you do, etc. We have to start thinking, start planning, start working on these issues. But I think just as in China during the Ming Dynasty, when you have Zhongye, who was circulating and learning more about the surrounding. As an explorer, in Europe, we had explorers who went to study what was beyond Europe, etc. Today, we have a fairly good understanding of what happens on Earth, but we still have to understand what is that surrounds us.
Yes, I understand that could offer valuable experiences for us to address the common crisis, including the climate change. And to you?
Yeah, I think studying the outer space, the Moon and Mars and beyond, including asteroid, can be connected closely to the Earth protections program. For example, Mars atmosphere has just 1% of that of Earth, and also just full of carbon dioxide. So the emission of carbon dioxide on Earth could also be a very negative thing in the future for climate change and protection. So some of the planet might had a history that you used to look like Earth, but now it become a very barren land, very uninhabitable places. So those are experiences that we have to learn and expand our knowledge to protect the Earth better. And second thing is the protection of Earth itself. A small asteroid might be coming at any moment, and we have to keep in constant eye on bigger space bodies that in a similar way destroyed our dinosaurs. So we have to protect the Earth in a way so that we don't have the small asteroid and other cosmic disasters. And third thing is to study the sun. There's a revolution every 13 or 12 years of the solar activities. That these activities also have close connections with the climate change, with also even human activities. And also space activity expanded our capabilities. Explorations on the moon will provide us with basic and fundamental knowledge. And the moon is so important to the Earth activity that is interactive all constantly with the Earth. And speaking of the moon, I think today is the perigee, or there's a perigee and apogee, which is the closest point between the moon and Earth. So we call it supermoon. So tonight we will see the supermoon,
yes.
Which is also close to the tide wave of the Earth. And the moon itself is just a generation of life on Earth. So there are many things that we're doing in space that is closely related to our lifestyle on the Earth. I was always following the ESA director, Jean-Jacques Dodin. He was saying that we should switch off space facility for one day, and we'll see that we're basically go back to the Stone Age. We don't have telecommunications. We can't drive the car because we have no navigations on the GPS and Beidou, and we basically have nothing from space that we can tell the weather. So space is very important. Space activity also very important to human lives. It's closely connected.
Yes, in a word, it's closely connected with all aspects of human life on Earth. So thank you very much, gentlemen. And well, we're going to have the launch of the core module of Tiangong in a few days, and our reporter will bring various information from Wenchang in South China's Hainan province. And perhaps in the future, we can have further discussions on collaboration or on some other aspect of the space science. Thank you so much.
Thank you.
Okay.
Thank you.
Okay.
Pleasure.